In this video, we'll explore some problems related to vector operations. Specifically, we'll look at an application of the dot product to physics in terms of work, and then we'll look at how to determine if two vectors are orthogonal. One of the applications of the dot product in terms of physics is using work in force diagrams. So work is done when a force causes an object to move a certain distance. Now, oftentimes, it's the simplest case is when the force is applied in the same direction as the object that's moving. However, in this case, we're trying to slide a crate across the floor. Now, a force of 50 pounds at an angle of 30 degrees is needed. And it's asking how much work is done if the crate is dragged 30 feet. Well, so what we'll see here is that, well, there are two components. So our force is actually heading in this direction, 50 pounds. Now that has both an x component and a y component that it's pulling on, that force. And it's moving a total distance of 30 feet. So if I want to look at the work done, well, work, you may be familiar with the physics equation, work equals force times the distance. And that times cannot be a dot product. It's the force dotted with the distance or the direction that it's moving. So in our case, what we want to really look at is, well, our work equals the force in the x direction times the distance in the x direction. And so here you'll have the force being applied in the x direction, and then this is our total distance that we have. So using the dot product, well, we know that that's the same as the distance, the magnitude of our force, times the magnitude of our distance, times the cosine of the angle between them. Now what we'll notice is that the force times the cosine of theta, well, that's giving us the force applied in the x direction. And then that distance is the distance that it's moving. And so we can calculate out, well, then work equals force, so it's 50 pounds times the cosine of 30 degrees times our distance, which is 30 feet. So now we have the force being applied times the distance that it's moving. And so 50 times the cosine of 30 degrees is the square root of 3 over 2 times 30. So that's 1,299. And the units on that are pound feet. So that's the English version. The scientific version would be Newton meters or joules to compute that. So we can use information about the dot product to compute the forces when they're not being applied in the same direction as movement. We need to find if the vectors 8, 3 and negative 6, 16 are orthogonal. Well, judging from our diagram that we drew, it appears that u and v are orthogonal, meaning that they meet at a 90-degree angle. Well, one way that we can prove that these vectors are orthogonal is using the dot product. And the reason we can do that is if we let u be our vector 8, 3, and we let v be negative 6, 16. Well, u dot v equals the length of u times the length of v times the cosine of the angle between them. Well, if we look, the length of u will always be a positive number. It's its distance, as well as the length of v. And the cosine of theta, well, cosine of theta is 0 if the angle is 90 degrees. So we know over here if theta is 90 degrees, well, then the cosine of theta will be 0. So their dot product will be 0. So I can use that information now to say, well, u dot v, I can use my rectangular coordinate version to say, well, that's the same as x1 times x2 plus y1 times y2. Now if that's 0, then I also know that they're orthogonal. So 8 times negative 6 plus 3 times 16. Well, that's negative 48 plus 48, which is 0. So the dot product is 0, so I know that the two vectors are orthogonal.